Hey guys, so this is mostly going to be for teachers in the field already working with School of Tomorrow, like as presenters of the slide decks and so forth. So, this storyboard that I've developed over the years, Saturday Academy was uh, one of my venues, right? Martian math. You're old enough now, you might be an adult and remember as a kid that you took this weird course called Martian math at the University of Portland or Reed College. These were host institutions. It was Saturday Academy that gave me these opportunities, and I have rearranged the slides, which means none of the links have broken. So if you've linked to some of these in your blogs or so on, it's not going to affect that. If you're, pulling these pictures into other contexts by URL, which I do all the time, um, you can put the same picture in multiple albums as well. But we talk about synergetics in the context of other mathematics as well, and other philosophy, and other anthropology. In other words, it's the context that matters a lot. And the small underground magazine has been a vector and will likely continue to be for this information. There's one of such small underground journals on the right there. That came out in the 90s, Synergetica Journal, and you can find it online. And if you're interested in jumping into this content and turning around, maybe teaching it, that's a good place to start. Test your Finder skills. I'll have a link in the description. So, Martian math, what is it? Portland Knowledge Lab. I came out with that after visiting the London Knowledge Lab and giving them a talk over some Easter period that most people were out of town. It was called a banker's holiday, but it was a fun talk and it was online for a while, but it's since been removed. These things don't last, let's just be clear. Like all things, right? Impermanence. I'm big on that. But speaking of semi-permanence, the Hoover Dam, this is an animation, and this gets us into an underlying theme in Martian math, which is the Martians. That's just a proxy, right? Martian can mean whatever you want. It can mean an other, right? You're othering on purpose. Because synergetics, the content of our math a lot, is alien, and we want it to sort of feel like we are learning it from another planet almost, or from an ET, or ETs. So the ETs in our science fiction story, because Martian math, by its very title, inserts us. It plugs us into. It insinuates us within actually the lineage we call science fiction today. Although I heard Ursula Le Guin once talk at Powell's, and she was clear that it's such a porous category. We almost just don't need it anymore. Like, so you're fiction and you've got science in you. That's enough to be a genre, maybe. In this case, I'd say we are in the lineage of science fiction, and it's helpful that there's a bio of Bucky out there by Alec Navala Lee, which really does integrate Fuller as an author into the science fiction tradition more than you might realize he should be or could be. But of course he can, right? Because he was a futurist. All of his work was science fiction in a way. And some of it we treat almost as if he thought we really would build a dome over Manhattan, for example. That's what I call conceptual art. Same with the geoscope floating out in the East River. Once you've kind of declassified that and put it out there, in a way, it's never going to happen. At least I do. Like, I never expected a dome over Manhattan. But as conceptual art, it teaches you about thermodynamics. What it would cost to heat that dome versus heating each individual building, that kind of thing. But you got to make it more dramatic to make it understandable to more people. So, same thing with these dams. I'm not saying that every time we do a camp, like a summer camp or whatever, that we're going to build an actual hydroelectric dam or something like that. But we might build a small, we might have models. But for certain, in our storyboards, the Martians are living in a base. They've come to this planet, something like maybe this is their base. You see the plane there for scale. This is my living room, looking pretty orderly here. It's changed somewhat. It still looks similar to this. If you've been here and visited me, you know what my place looks like. And it's the School of Tomorrow headquarters, right? You can see that on my websites. And this is back out teaching again. This looks like probably a Saturday Academy experience. This is my workspace, my personal workspace, where obviously I have a lot of what we could call models, but we could also call toys. And these are pictures as well. For you, as a teacher out in the world, you don't have to own all this stuff or duplicate it necessarily in order to make use of the sphere packing in a tetrahedron concept. And tetrahedral numbers, triangular numbers, sequences, and then intervolume relationships. That's the key to Martian math, this concentric hierarchy, we call it, of co-concentric polyhedra intersized in very specific way with the tetrahedron as our unit of volume. So part of having a camp, or let's call it a city-state, a town, I don't know what you want to call it, an urbanish kind of village associated with building the dam, like the Glen Canyon Dam, where my friend Glenn grew up as a kid. You don't have a dam without workers. You don't have, a camp without people. So obviously we're going to have dwellings, we're going to have pods of different styles. And the point here in Cascadia is to prototype. So what exactly these pods are like? Well, there's quite a few that we have our eye on in China. And the first camps might well be kind of in Mongolia, Siberia area. It's not required that we do these in Cascadia. This is more like kind of like we're Nike. We plan stuff, we design stuff, but we don't have to do stuff here in Cascadia necessarily at the beginning anyway. So we've got these, but we might, right? I mean, you could say we already are because this curriculum's already percolating out and there's a lot of awareness and so on. You could say the Silicon Forest is already its own little kind of, we got the dams too. It's just that they're already built, right? Most of them, they're even taking dams out. We got a surplus of dams because they mess with fish, and that's a big part of the ecosystem here as much as power generating. I mean, fish in themselves are, they belong in the equations, right? Optimization and all that. Okay, so when it comes to the tetrahedron as measuring an amount of energy, this is typical in thermodynamics, that energy can be seen as like a liquid in that it's quantified and then it's conserved. To the extent that it is conserved, we can treat it as a liquid. And there's the potential energy, there's kinetic energy. So as potential energy turns into kinetic energy, we can show a tetrahedron shrinking. And we can talk about third powering, and we can talk about, right, the draining away of the water. And we can talk about the corner angle, like this is corner angle of 90, 90, 90. And when I say reorganized, I've got these more together now. Like all of my pictures using this particular toy system are in sequence. And so there's our 90, 90, 90 degree angle, which is the cultural norm for getting volume going as a concept. We went with right angles. We did not go with the tetrahedron. There was a fork in the road, and synergetics is like, what if we'd gone down this other fork, this other road? And in a lot of ways, you could feel like it's kind of retro, and that it feels like it's something that maybe the Greeks could have discovered and gone with. And they were all they had a lot going on with geometry. They developed a whole philosophy around it. And you could say what would have developed, subjunctive tense, had synergetics, had the unit volume tetrahedron idea gained more traction. in Greek times going forward, there'd be a lot of philosophy. You could call it cruft. I wouldn't necessarily call it cruft. Depends because it doesn't exist. So it's your science fiction how you want to tell that story. But in the meantime, we have it in the 70s, and it's been 50 years. So we've seen, and it came out already in Synergetics 2 volumes and Tetra Scroll and Critical Path and Crunch of Giants, fully developed as a philosophy. And that's why the context of philosophy, of course, matters. But let's just look at the Tetra book here. This is where you put two equilateral triangles like book covers flat to the table, open 180 degrees, and then you have a flap that goes back and forth between the two page tips, and if it stops here, you get the regular tetrahedron, and you could call that unit volume. There you go. See, it's like slanted in such a way that a regular tetrahedron is formed. You can imagine the missing edge there, and actually an edge from the tip to the other cover page, the other cover tip, that's also going to be the same volume, roughly base times height. You can think of it that way, but we compute volume differently. Here it's the two of them side by side. In green, you've got the right tetrahedron, so that's different now. You see the attempt at a right angle, right? Let's make that bigger. The right angle shows a right tetrahedron, and all the edges except the longest one are going to be D. D is the diameter of a CCP ball or IVM ball. They're all blue on the other side. That's the regular tetrahedron with edges D, all edges D, right? There's no longer edge. It's the right tetrahedron has the longer edge. And then this D does not label that green edge because it's longer than the blue ones. These others could have been blue, like the color coding here doesn't actually follow the links as closely as it could. But the point is, the ratio between these two volumes is the second root of 9/8 or 8/9, depending on which one you put in the denominator. And that's going to be like a conversion constant for us because it turns out that the R-edged cube, in other words, take that ball with radius R and diameter D, D equals 2R, and take that length R and build a cube out of it. That's going to be your typical unit volume in sort of orthonormal orthodoxy, where we all grew up as kids, right? So when you go to these camps and they teach you this Martian math with the Tetra book and so on, you're going to go like, wow, this is alien. I didn't get this in school. Now that's in 2026, you didn't get it in school, right? It's already way late. That you're not getting this in school is a tremendous, amazing lag time. Like I would never have thought schools were this slow. But I've gotten used to that idea, and I've changed my meaning of school now. It's like it doesn't make sense to call a lot of these places schools where they don't teach this, right? At all. I mean, they don't even allude to it. And that leaves you so out of the loop, I have to say. So we look at Martian as a meme throughout the culture. We gain practice in anthropology and meme analysis and subcultures and cultigory theory, all that stuff, simply by tracing the meaning of Martian in our culture. But we don't lose sight of the global grid and what we're doing with the Martians, which is collaborating, building a dam together, a hydroelectric dam, and they use the unit volume tetrahedron as their unit of volume, and we, the Earthlings, are stuck with the cube because that's historically accurate. That's where we're coming from. Now, at the same time, the curriculum is going to introduce that we are, as a planet, thermodynamically not a closed system. You get a lot of people who think they know economics who talk about how Earth is a closed system, right? They're completely misinformed. These are people you don't want in your schools. But whatever. I think people coming back from the camps are going to look at their schools in a different way. They're going to say, man, you guys need to learn about Martian math a little bit and how we do A times B in like, quote, 2 dimensions, right? In a plane, flat, like with these chopsticks and stuff. This is like 1 times 1, and we've been looking at A times B. And, I won't go into all this yet again because you're able to come back to this. And so this is 1, 2, 3, 4, 5, 6, right, times 2 is 12. So the area, the green area is 12. And yet the whole thing is 1, 2, 3, 4, 5, 6, 36. 36 minus 12 would give you the remaining area, stuff like that. So it's very kid-friendly. You don't have to be like the next Einstein to like comprehend what's happening here. There's the area 24, right? 4 times 6. And then we take it into volume after we play around with these by David Koski, by the way. Using VZome, Virtual Zome. If you haven't heard of Virtual Zome, again, are these schools that you go to or daycare centers? I'd say daycare centers. You're in a holding tank. They don't have relevant material. You know it. They know it, right? So here's 4 times 3 and 7 times 10. You get the idea, right? And then we move to 3 dimensions, you could call it. So 2 times 2 by 5. We call it 4-dimensional pre-frequency until we start frequencing, and that means adding energy, but you can have frequency in pure principle, blah, blah, blah. You'll learn the vocabulary when you show up. If you show up virtually or if you show up in person, BFI has similar programs, right, as School of Tomorrow. This is a whiteboard drawing. I've been using, my group is called the Wanderers, and this is at a meetup of the Wanderers many years back, 2010, where I'm, doing this material. And through the Wanderers, people have learned that they can present this. And that's why I say at the beginning, if you're already working with the School of Tomorrow, because I have a small army, you could say, quite small. But who knows, by the time this video is aged a while, there could be a lot more. So this is relevant going forward. Why do I call this 12 frequency? Because I count the number of intervals between the balls, and that will give me information about how many total balls there are. And it relates to the diagonal of the cube, and we can compute its volume. The ratios are all going to make sense here, but you really need to start out by understanding why we can have a unit volume tetrahedron in the first place and how it gives us these other nice whole number volumes that currently are being withheld from you, except not in Bhutan. I call this a Bhutanese math curriculum. I did this way back in the 80s. Right, that's what I mean by we don't have to do this in the what we call the United States, because the resistance here to its own native, indigenous, futurist person who put his whole life into trying to communicate all these concepts, the resistance here has been enormous, right? They don't teach it at all in most schools, quote-unquote schools. And I'm saying, yeah, this is precisely the wrong place to try to push this stuff, because they still, the way they play world game around here, they still imagine all this weird stuff about world game. I don't know. It's just, I have a hard time talking to Americans, let me tell you. They're not my people in some ways, right? Because I grew up as an expat and I saw the world from the outside. The world meaning the way, if you grew up here, you really at a disadvantage. So in a way, I want to do all this stuff here, because where are people more ignorant than in North America? Anyway, there's the Genesis story, which you know already. I won't go through it again. The Linus Pauling archive, you know about that. And again, back to my place, the backyard, and C6D, and all the memes, right? So this is the kind of small-scale stuff that a summer camp might feature, because we're learning the principles of electromagnetism, right, and how big grids work. And it's this idea of the concrete bucket. This is from the animation. I give the URL in the descriptions of the individual pictures. That's what we can use as a volume measure, Remember how we can, like cooking too, we can use cooking cups, measuring cups. Like the tetrahedron could be a quarter cup, the octahedron could be a cup, you know, like that. And 6 quarter cups makes what? And that would be the rhombic dodecahedron. It's up to you, right? You're the teacher. You can do these different things. But the Earthlings and the Martians, when they're pouring concrete from one of these cranes, like I'm showing you, these are lowered down to fill up the dam, make the concrete that is the dam, right? You got to learn a lot about construction in that case. Like we go through dam construction in some detail in these camps. The unit of volume for the Martians is going to be a tetrahedron, unit edge, unit volume. And when I say unit edge, I mean, of course, with reference to a standardized sphere or ball or length, because once you have a length, you can sweep it omnidirectionally around and you get a ball, its sphere of influence or whatever you want to call it. So R is half of D. This is maybe not to scale so much, but again, the idea of the synergetics constant you must have, right, if you are going to understand synergetics, and you need to understand how a unit edge, unit volume tetrahedron gives us a consistent, rather alien seeming math that is being withheld from you, especially if you live in a place with a lot of pretensions to like having its act together. It doesn't need any of this information. It's like, we don't need to teach any of this in school. No, because we're teachers and we know what's important. Yeah, right. Yeah, right. Anyway, so that's the Martian math, and I hope you already know about it actually, and good for you if you're presenting this in your school. And as a kid, right, you want to do show and tell. You can take this to any good school that allows show and tell, if the kids are even allowed show and tell. Show and tell about this stuff, right? Get your feet wet. You don't have to let me know, but you can if you want. And join the club. Join the club of people who know something, right? This is a good gear to make a big stride forward and learn what you've been denied. It's your right. All right. Talk to you later.